Another Earth Science video on the way. This is Norris Teaches Science, Earth Science Edition, starring me, Mr. Norris. And today we're going to talk about the moon. So by the end of this video, you should be able to say, I can explain how the moon affects the Earth. So first off, let's talk about seasons. Just summarizing some, just revisiting stuff about the Earth's motions. Remember, the Earth revolves around the sun. It rotates. And the Earth's axis is tilted 23.5 degrees. Well, that tilt of the axis is the reason why we have the seasons. That, and because we have revolution around the sun. So the tilt of the axis, it is tilted 23.5 degrees. When it's tilted, when it's around in the revolution of the sun, and the tilt is more towards the sun, that area is going to have warmer seasons. And if it's tilted away from the sun in the point of the revolution, then it's going to be the colder seasons. The tilt doesn't change as it revolves around. It's just going around. Now, this does factor in with hemispheres. Remember, we have the northern hemisphere and the southern hemisphere. It's divided at the equator. The northern hemisphere will always have the opposite season than the southern hemisphere. So my example here is if it's summer in the northern hemisphere, that means it's winter in the southern hemisphere. So the opposite of spring is fall. So I live in the northern hemisphere. At the current point, we are in the middle of spring when I'm recording this video. I don't know what time of year you're going to be watching it, but since it's middle of spring here in the northern hemisphere, it is the middle of fall in the southern hemisphere. Now the moon. Now, the origin is still debated among scientists. We don't really know exactly how we got the moon. There's many different theories out there, and I suggest you go look up those theories on Google. So there's just competing theories. Now, the moon does have less gravity than the Earth, but one thing the moon does it factors into our tides, the rise and fall of sea levels. Now, the rotation of the moon is 27 days. That means spinning on its axis. And its revolution around the Earth is 27.3 days. So most times people say you only see one side of the moon or the dark side of the moon. Because the rotation and revolution are about the same, that is why. Now, the moon phases. The moon has multiple phases and is caused by the reflecting of the sunlight on its surface. So as you can see down here, here's the sun. And it shines towards the moon. When we'll start at the new moon, and we always wax on to the full moon. And you go to the waxing crescent, the first quarter, the waxing gibbous, then the full moon. Full moon is basically saying that it's reflecting all the sunlight that hits it. Then we wane off of the full moon, the waning gibbous, the last quarter, and the waning crescent till we get back to the new moon. The way I remember it is I think of a movie, The Karate Kid, wax on, wane off. Wax on, wane off. And that's how you do the moon phases. I suggest you guys stop this video here, maybe pause it, sketch out what these moon phases look like, especially where the sun is compared to the moon, so that you have it for a good study tool. Now, tides. What causes the tides? I kind of mentioned already that the moon causes the tides. But a tide is the change in elevation of the ocean surface or the water surface. Now, the tides are caused by gravitational pull of the sun and the moon. The sun and the moon both play a factor into our tides, but it's mainly the moon that factors into our tides. That causes us to have really two types of tides, a spring tide and a neap tide. Spring tides happen during either the full or the new moon, And that's when the pull of the moon and the sun are added together. So it causes us to have extreme highs and extreme low tides. It's really bad in my area for us to have a spring tide right near like a hurricane because it causes our storm surge and coastal flooding to be worse. Now, neap tides happen during the first and third quarters. That's because we're at a parallel here. So the gravitational of the moon and the sun are battling each other. So the tidal range is really small. So you really want a neap tide during a hurricane in the area where I live. Tidal patterns, it does depend where you are in the world, your tidal patterns. You can have diurnal tidal patterns. That's where you have one high tide and one low tide a day. If you think of Southeast Asia, that's kind of what they have. Semi-diurnal, you have two high and two low tides a day, like the Atlantic coast of the United States. I live on the Atlantic coast. I live on the East Coast, and we do have a semi-diurnal tidal pattern. We have two highs and two lows every day. And then you have mixed tides. This is like a combination of diurnal and semi-diurnal. And the Pacific coast of North America exhibits this type of tidal pattern. This is the moon, how it affects the Earth. I hope you learned something today. And this is Mr. Norris, and he is signing out for this video.